Across Egypt's western desert, an enormous engineering challenge begins in one of the harshest landscapes on Earth. Here, water is scarce, vegetation is limited, and the landscape offers almost no natural path toward large-scale agriculture. Yet beyond the barren landscape, Egypt's cultivated regions show exactly what becomes possible when reliable water reaches the soil. The plan follows a vast engineered route, carrying water deep into the western desert across hundreds of kilometers. Before machines can dig, engineers must establish the exact route, measuring the land with extreme precision. GPS receivers, laser levels, and digital terrain data turn an apparently empty desert into a precisely measured construction site. Then the first excavation begins, with heavy machines cutting through compacted earth to establish the waterway's foundation. Every cut removes another layer of desert, while hydraulic systems deliver the enormous force required to reshape the ground. The excavated material is loaded continuously, beginning a massive cycle of digging, hauling, dumping, and reshaping the desert. What begins as a single excavation rapidly expands into a coordinated earth-moving operation stretching deep across the desert. Excavated earth now moves through a continuous transport cycle, clearing the route and preparing the ground for its final engineered profile. Bulldozers spread the removed material, gradually transforming rough excavation into a controlled construction surface. Precision graders now shape the channel, removing only the material needed to create its carefully calculated geometry. The final grade is controlled by digital guidance, ensuring the channel follows the intended elevation and slope with remarkable accuracy. As excavation deepens, the channel begins to take its final form, with controlled side slopes guiding the future flow of water. Compaction follows excavation, forcing loose particles together and creating a stronger, more stable base for the engineered waterway. Field testing verifies that the compacted foundation meets the required density before the next construction layer can begin. Before protective layers are installed, every section is cleaned and prepared so the finished surface can remain stable under constant water movement. Where protective lining is required, controlled concrete placement creates a durable surface between the moving water and the desert soil. Section by section, the desert is reshaped into a continuous engineered corridor, bringing the project closer to its ultimate purpose, moving water. Reinforcement is positioned along critical sections, adding structural strength before the waterway enters its most demanding stage. Mechanical vibration removes trapped air, helping the fresh concrete settle into a dense and consistent protective layer. Finishing crews smooth the surface by hand, removing irregularities and preparing a continuous path for future water flow. Long structural sections are joined with deliberate precision, creating an uninterrupted engineered corridor across the desert. A constant supply of materials keeps the construction moving, with trucks feeding separate sections as crews work along the route. The surrounding shoulders are shaped and stabilized, protecting the finished channel from loose desert material and erosion. Construction does not stop with daylight, as illuminated crews continue preparing the waterway through the night. Under artificial light, hydraulic machines continue the heavy work, extending the engineered corridor while the surrounding desert disappears into darkness. Before water enters, the finished section is inspected from end to end, checking the surface, joints, geometry, and surrounding structure. The excavation phase is transforming into infrastructure, creating a long controlled pathway ready for the next challenge, moving water across the desert. The completed channel is only one part of the system. The next challenge is moving enormous volumes of water into this engineered network. At the pumping station, massive structures control the transition between the water source and the long-distance conveyance system. Inside, enormous electric motors provide the mechanical force needed to move water through the system at controlled pressure. As the drive system starts rotating, mechanical energy is transferred into the pump assembly and ultimately into the moving water. Pressure builds gradually as valves open, allowing the system to introduce water into the main conveyance route under controlled conditions. Inside the conveyance system, the water accelerates through enormous passages designed to move it efficiently toward the desert network. Across the desert, the conveyance network carries water toward the engineered channels and the agricultural areas beyond them. At the connection point, the first controlled flow enters the channel and begins the long journey across the desert. The engineered slope now guides the water forward, turning a carefully calculated construction profile into a functioning hydraulic pathway. The separate components now become one system, connecting pumps, pipes, channels, and the desert landscape through a continuous flow of water. With the channel now carrying water, the engineered slope continuously controls its movement across the otherwise barren landscape. Control gates regulate the flow, allowing operators to manage water levels as the system responds to changing demand. Inside the control station, engineers monitor pressure, flow, and water levels to keep the entire network operating within its designed limits. Along the route, maintenance teams inspect the channel continuously, looking for structural problems before they can threaten the water supply. Even small joints receive detailed inspection, because controlling leakage is essential when water must travel through an extremely dry environment. Beyond the main channel, smaller distribution networks begin carrying water toward the land where new agricultural fields can be established. Controlled irrigation begins transforming dry soil, delivering measured amounts of water exactly where developing crops require it. Where desert soil once remained barren, carefully supplied water allows the first young crops to establish themselves in organized rows. As irrigation expands, agricultural machinery begins preparing larger areas, turning isolated green plots into a growing cultivated landscape. The result is visible from above, a controlled water network feeding new fields, creating islands of cultivation inside the vast Sahara. As the fields mature, irrigation must remain precise, delivering enough water to sustain crops without wasting the resource. Sensors measure soil moisture in real time, helping operators adjust irrigation according to the actual condition of the fields. Before reaching sensitive irrigation equipment, the water passes through filtration systems that remove unwanted particles from the distribution flow. Automated valves divide the supply between different fields, balancing pressure and directing water according to changing agricultural demand. Maintenance crews also inspect buried connections, where even a small leak could reduce the efficiency of the wider irrigation network. With water reaching larger areas, mechanized agriculture can operate across fields that were once dominated entirely by desert. The boundary between cultivated land and untouched desert makes the transformation especially clear, showing exactly where controlled water has changed the landscape. The waterway now links two contrasting worlds, carrying a controlled supply from engineered infrastructure toward increasingly productive desert fields. Behind the scenes, pumping and monitoring systems continue operating after sunset, maintaining the flow needed by the expanding fields. At night, the scale becomes visible from above, a network of water, infrastructure, and agriculture crossing a landscape once defined almost entirely by dryness. Through the night, the pumping equipment continues its cycle, maintaining the controlled pressure required to keep water moving across the network. Inside the control center, live measurements reveal how the system responds to pressure, demand, water levels, and changing field conditions. Remote sensors provide another layer of control, continuously measuring conditions along the waterway without interrupting its operation. As morning returns, the flowing channel reveals the scale of the engineering more clearly, stretching through kilometers of otherwise barren terrain. With reliable irrigation established, field workers can focus on crop development, maintenance, and efficient use of the available water. Modern agricultural machinery works between the rows, allowing large areas of newly cultivated land to be managed with precision. Precision irrigation places water directly where roots need it, reducing unnecessary loss while supporting consistent plant growth. From above, individual fields combine into a much larger agricultural pattern, extending the productive footprint deeper into the desert. Where roads and infrastructure intersect the water network, engineered crossings keep transportation routes functional without interrupting the flow. The transformation is no longer isolated to a single channel. Water infrastructure and agriculture are becoming one expanding system across the desert. The waterway now reaches the expanding agricultural frontier, where carefully controlled flow begins supporting much larger areas of cultivated land. Storage and distribution basins help balance the supply, allowing water to be divided between multiple agricultural zones as demand changes. At distribution junctions, one continuous supply becomes several controlled flows, allowing different agricultural areas to receive precisely managed volumes. Pumping equipment at the distribution level, maintains the pressure needed to move water efficiently through the smaller agricultural networks. At first light, irrigation begins another controlled cycle, supplying mature crops across carefully organized agricultural rows. Moisture is checked beneath the surface as well, ensuring irrigation reaches the root zone without creating unnecessary saturation. Once crops reach maturity, mechanized harvesting demonstrates the final stage of the transformation from irrigated soil to productive farmland. Harvested crops now leave the fields through an organized transport chain, connecting the reclaimed land to the wider agricultural operation. From above, the reclaimed landscape shows the cumulative effect of the project: water infrastructure supporting a growing agricultural footprint inside the Sahara. From engineered water control to cultivated fields, the system demonstrates how infrastructure can redirect a scarce resource across an immense desert landscape. What began as an enormous engineering challenge now appears as a functioning water network connecting infrastructure, desert, and newly cultivated land. Behind the transformation is a continuous industrial operation, where pumps, controls, and infrastructure keep the water moving day after day. At water level, the transformation feels simple: a continuous flow moving forward, guided by kilometers of carefully engineered channel. The fields reveal the project's most visible outcome: productive agricultural patterns appearing where the surrounding landscape remains overwhelmingly dry. From a barren desert to a connected water and agricultural system, this is the scale of engineering required to make the impossible begin to grow.